Yes, today I'm going to present to you my third assignment on real-time rendering. My name is Varun. I'm a postgrad at Trinity College Dublin. So the project has been set up using CMake. First of all, I'll show you the different maps that have been integrated into the project. First up, we have the albedo or the diffuse color, which essentially gives the color to the object. Next up, we have the normal map, which gives the illusion of depth to the object without actually adding geometry, which is pretty cool. It changes the way how light interacts with that particular object or the surface. And the third we have is the roughness map or the specular map. So I'm using these terms interchangeably, whereas they might not be used interchangeably. So in most 3D softwares or DCCs, we refer to them as roughness maps instead of specular maps. So each object supports multiple maps. We can also have an AO map or an alpha mask, but I've not implemented the functionality for that yet. Next up, I have some empty channels or some empty maps. So if I turn off the specular map, it will just switch it for a whole white image. Or if I turn off the normal map, it will switch it in for the default values that are being shown on the screen. I have a little correction there where the default values in the shader code are 0.216, 0.216 and 1 respectively, the RGB respectively, and we have 128, 128 and 255 on the 0 to 255 scale. So next up we have the way the whole project has been set up. So like you can see that first I'm passing the XYZ coordinates, and I'm passing the UV coordinates, then I'm passing the normal coordinates, and then in the end I'm passing the tangent coordinates, which have been read using the async library using one flag. So moving on into the scene, we have a resizable window and we have some lights, one directional light and 3-point lights, which will be showcased later. But yeah, so first of all, as you can see, the scene is pretty dark, so I'm going to change the diffuse and ambient intensity of the directional light, which makes the scene a bit better to look at. Next up, I'm enabling the environment mapping, which essentially enables reflections in the scene. And since we have a specular map, the amount of reflection has been controlled by that particular map. I have sliders for the particular maps. I can turn down the strength of the specular and the normal maps. So right now there is no normal presence in the material. As you can see, the specular presence is more because the map is turned off, so it has been replaced with a whole white image. Next up, I'm just showcasing the different maps in the scene that I have loaded onto the objects. So in the order of albedo, specular, and normal maps. So moving straight on to the showcasing of the normal maps, I'm just going to change the environment map so that it's a bit better. Turning back the specular up to 1, we see that there's a small change in reflections. And turning up the strength of the normal map slowly, we can see that the reflections are going away and it's turning more into a wooden texture. So you can see that there is an illusion of a bump or of some detail in the particular object, whereas the geometry remains constant. So this is the power of a normal map. Now you can see that the floor is looking pretty wooden and the crate is also looking pretty wooden. And if I turn the normal map up to 1, you can see that it's totally wooden and we are getting nice reflections as if it were real wood. Again, the geometry is the exact same. We have one single plane with 4 vertices, or you could say 2 triangles, and changing the direction light changes the way light is interacting. So we get shadows from different angles and it interacts pretty realistically. So like you can see, changing the direction of the directional light or the sunlight, we get different kind of shadows. So this was the normal and bump mapping. The maps are used to change the direction of the light. So since in real world nothing is totally free of bumps, so similar is the case with 3D. Since we want to simulate the real world, we make use of various techniques to maintain the performance while keeping the look. So if I enable the point lights, I'll turn down the normal maps to 0 again. So like you can see that I can see the reflections of the skybox as well as the point light, but increasing the strength of the normal map distorts everything, and I get much more realistic results. So even the pointlets are interacting with the normal map, and they're giving shadows based off of the normal map. So that was my showcase for this assignment. Thank you very much for watching, and see you next time.